Hello, curious minds. What if the strangest comet we've ever seen is 3 billion years older than Earth itself? Now, we already made a video on 3I/Atlas and introduced its main characteristics. But reading the latest news, here's where things get really weird. Most comets we've studied in our solar system have comas dominated by water vapor, with carbon dioxide making up only a fraction. But 3I/Atlas, it's the exact opposite. Observations with the James Webb Space Telescope show that 3I/Atlas has nearly 8 times more carbon dioxide than water in its coma. That's one of the highest ratios ever recorded in a comet, about 6 standard deviations away from the average. In other words, this isn't just unusual, it's basically off the charts. And if that wasn't strange enough, astronomers using the Very Large Telescope detected atomic nickel vapor streaming off the comet. But here's the kicker, no sign of iron at all. Normally, nickel and iron show up together in cometary emissions, since they're chemically tied in most planetary materials. The fact that 3I/Atlas is spewing pure nickel without its usual partner hints at some alien chemistry we've never encountered before. Put together, these findings suggest that 3I/Atlas formed in an environment radically different from our solar system. Maybe it was born in a colder region where water couldn't condense as easily, leaving carbon dioxide to dominate. Or maybe the processes that shaped it involve conditions we don't even have in our neighborhood of the galaxy. In short, 3I/Atlas isn't just another icy rock passing by, it's a chemical rebel, rewriting what we thought we knew about comets. If the chemistry of 3I/Atlas is surprising, its age and size are equally mind-bending. This interstellar visitor may have formed in the Milky Way's thick disk, an ancient part of our galaxy, making it potentially billions of years older than Earth itself. In other words, we're looking at a time capsule, carrying material that has been traveling across the stars for longer than our planet has even existed. And it's not small. 3I/Atlas is estimated to be around 7 miles or 11 kilometers across, making it the largest interstellar object we've ever observed. To put that in perspective, that's about the size of a small city, an enormous icy traveler drifting through space, cloaked in a fog of carbon dioxide and trailing nickel vapor. The sheer scale of this object means that its chemical oddities aren't just tiny blips, they represent massive amounts of material, giving us a rare window into alien chemistry and ancient galactic history. When you combine its age and size, 3I/Atlas isn't just a comet. It's a relic from another star system, offering us a glimpse of conditions and processes that existed billions of years before our solar system formed. So far we've talked about 3I/Atlas's strange chemistry and staggering age and size, but what are astronomers actually seeing as it speeds through our solar system? Here's where things get visually and scientifically fascinating. First, the comet's activity is abnormal from the very start. Most comets don't begin forming a coma until they're closer than Jupiter's orbit, 5 astronomical units from the Sun. But 3I/Atlas started glowing and producing a tail well beyond Jupiter's orbit, about 6.4 astronomical units, which initially led some to speculate wild theories. The explanation? Its tail is rich in carbon dioxide or dry ice, which sublimates far more easily than water ice, allowing a coma to form at much greater distances. Second, polarimetric observations, basically measurements of how light scatters off the coma, show unusually high negative polarization at small phase angles. This suggests the coma is a unique mix of icy and dark material, different from what we see in comets from our solar system, giving clues about its exotic origin. Third, telescopes like James Webb Space Telescope, Hubble and SphereX are tracking it across multiple wavelengths, capturing detailed spectra of its gases and dust. Already they've confirmed the extreme CO₂-to-water ratio and the pure nickel emissions, while upcoming observations may reveal even more surprises about its dust composition, outgassing patterns, and how the tail evolves. Hubble observations also revealed something unusual. 3I/Atlas does not have a classic tail shaped by solar radiation. This could mean one of two things. Either the nucleus is incredibly massive, potentially 1,000,000 times larger than the previous interstellar visitor, 2I/Borisov, or the surface has unusual properties that prevent a typical tail from forming. Its trajectory, nearly perfectly aligned with the plane of the planet's orbit, has even sparked speculative theories, though all evidence points toward natural cometary processes. Finally, the comet's motion itself is a highlight. Moving at high speed relative to the Sun, 3I/Atlas is a rare opportunity to study an interstellar object in real time, allowing astronomers to test models of comet formation, evolution, and the dynamics of objects that originate outside our solar system. Taken together, these observations don't just make for beautiful pictures. They give us real insight into the physical and chemical processes of a comet from another star system. While Earth-based telescopes have revealed a lot about 3I/Atlas, some of the most exciting discoveries are still to come, and they'll come from spacecraft already in our solar system. First up, on October 3, 2025, the HiRISE camera aboard the Mars Reconnaissance Orbiter will get a rare close-up, passing just 29 million kilometers from the comet. This observation could finally reveal the size and shape of its nucleus, separating the solid core from the surrounding dust and gas for the first time. Next, NASA is exploring a bold plan for the Juno spacecraft. A trajectory adjustment in September 2025 could send Juno on a flyby of 3I/Atlas in March 2026, allowing its advanced instruments to study the comet's composition, outgassing, and surface properties, giving us data that no Earth-based telescope can capture. The European Space Agency isn't standing still either. On October 3, 2025, Mars orbiters like Mars Express and the ExoMars Trace Gas Orbiter will attempt to observe the comet during its close approach to Mars, potentially detecting water vapor, organic molecules, or other chemical signatures in its coma. Meanwhile, the JUICE mission, ESA's Jupiter Icy Moons Explorer, will be in a favorable position during the comet's perihelion in November 2025, thanks to a gravity assist from Venus earlier in its journey. This positioning will allow JUICE to collect valuable data on 3I/Atlas's activity and composition. Finally, looking further ahead, the Interstellar Comet Explorer, or ICE, has been proposed by the Southwest Research Institute as a dedicated mission to fly by objects like 3I/Atlas. While still in the proposal stage, ICE could one day give us unprecedented close-up insights into the origin and makeup of interstellar visitors. Taken together, these upcoming spacecraft observations make 3I/Atlas not just a comet we watch from afar, it's a once-in-a-lifetime target for real-time interstellar science. 3I/Atlas is more than just a comet. It's a messenger from another star system carrying chemistry we've never seen before. So, what's next? Could the next interstellar visitor bring not just chemistry, but the building blocks of life itself? Let us know your thoughts in the comments. If you enjoyed this cosmic journey, don't forget to like, subscribe, and ring the notification bell so you never miss a signal from the stars. Thanks for watching. Until next time, keep looking up.